Yes?
Okay, so hello everybody. My name's Carl from DSP Robotics, and we're here to present the FlowPaw Build Your Own Gizmo Kit today. Quick thank you to Conrad for hosting this webinar, and we're going to go through a little itinerary of looking at hardware, how to program it, and then we're going to have some questions and answers at the end. So, first of all, what is FlowPaw? And this is the FlowPaw box that you get when you buy the product, and inside you get this, which is basically the FlowPaw board, and underneath are some click boards which plug into claw sockets, and in the basic kit you get this one, which is an 8x8 LED display. You get this one, which is an accelerometer, which knows the sort of 3D orientation of the FlowPaw board, a proximity sensor, a buzzer, and a USB cable. You also get a little pouch with CDs and manuals and that kind of stuff. Okay. In addition to the FlowPaw kit, there's also additional clickboards available, and they come in these boxes like this, and inside here there's two different click packs at the moment. This one's got an RFID reader, voice recognition, a gyroscope, and a Bluetooth interface. And this one here has, let's have a look in this one, we've got an infrared temperature sensor, a relay, a 7-segment display, and a touch-sensitive, like CapSense switchboard. Okay, so that's the basis of the hardware. Now let's look how we connect the whole thing up. So, if we look at the FlowPaw board, let's just have a look what's actually on this board. It's shaped a bit like a paw, like a bear's paw. That's where the name comes from. And on here there are 4 what we call claws, which are sockets for plug-in boards. So you've seen the little clickboards. In addition to that, on the right-hand side, there are 8 servo outputs, so you can control remote control servos, and also motors to drive wheels and that kind of thing. So there's 8 outs there. There's also a little power connector here just for the servos. So if you are connecting it to something that needs a bit more power, like a robot arm, you can just move this little yellow jumper across and use external power instead of internal power. So that's the servo inputs. On the left-hand side, we've got this little 10-way header, which is 4 analog ins, which are 14-bit, and 4 digital ins, sort of 1 and 0, so you can connect ancillary products. And to help with that, there's also a little power header here with 5 volts and ground, and there's also 3.3 volts on this header. So that's the basics of the hardware. There's also 4 LEDs here, 1, 2, 3, 4, and 4 little push buttons. So to connect our FlowPaw, it's quite simple. We'll just plug it into the USB of your PC on a USB 2 port preferably, and then the computer will automatically find the board. There's no drivers necessary. And once it's connected, hopefully you can see these 4 LEDs are flashing to say I'm alive. And we are now able to connect to the board. So in FlowStone, in order to do that, we have the FlowPaw module. So if you just search for paw in FlowStone, this is my FlowStone project. I can blow that up a little bit if it helps. There we go. Okay, so this is the software emulation of the hardware. And in most FlowStone modules, you have the inputs on the left and the outputs on the right. So here there's things like start, LED inputs, servo speed, and on the output side there's whether it's on or off, information, the 4 button outs, the 4 analog outs, the 4 digital outs, and then at the bottom we've got these 4 claw connectors, which are to connect to a range range of claw modules. So to start our FlowPaw, the first thing we need to do is send a trigger to the start. And there's a very easy shortcut for trigger, which is Z on the keyboard. And then we can just wire that straight to our trigger. We can also put, say, an LED on the on output to see if we are connected. So currently we're not connected. And if I press go on here, you see the light comes on and the little lights go off on the FlowPaw. So we now have control. So if I wanted to switch an LED on, I could just get something like a switch. Here's a big switch, and just wire that into LED number 1, and then when I switch it on, hopefully you can see on the FlowPaw video the little LED going on and off. Okay, so that's the sort of basics of controlling the FlowPaw module. Before I go any further, I want to just cover a few of the basics in FlowStone so that you understand some of the variables. In computer programming, we have various types. These can be things like bools, which are true or false. That's B on the keyboard. So that's something that can be just true or false. And if I can connect an LED to that on the screen, you can see when it's true, it turns the LED on and off. We have things like integers, which are D on the keyboard, and these are whole numbers, so 1, 2, 3, 4 kind of thing, or negative numbers. We also have floats, which is F on the keyboard, which are basically fractions, let's say. And we also have strings. So strings are usually text. Okay. And inside FlowStone, we can connect various ones of these together and do automatic type conversion. So if I have an integer here and connect it to a float, if I put 10 in there, you'll see it's 10 in the float. And if I then connect that to a string, it's also converted instantly to a string. So if I reorder these like this to illustrate the difference between floats and integers, if I put 10.5 in there, you'll see that the integer rounds it off to the whole number. So I'm going to be using a lot of these. So just to recap, bools is B on the keyboard, integers is D on the keyboard, floats are F, strings are S. You'll also see on some of the modules this little P symbol, and that's for parameters, and that enables you to go in and select different things. So in this case we can choose different colours for the LED, so it's now a red LED. So there's lots of those on different modules. And we can also go into the module, so what's inside the LED, we can double click on there and we can actually see the code underneath that. So most things in FlowStone are sort of open source, where you can go and look at the code and hack it and change it to be whatever you want. So for example, here on the switch we can go inside and see the code inside the switch. Okay, so let's connect some things to our FlowPaw. The first thing we're going to do is plug in a 8x8 display, and good practice is to disconnect your FlowPaw while you connect any electronics. So I'm going to plug that into claw number 2, put that back there, and in order to connect to that I need to find the 8x8 claw now. So you see it says claw 8x8 LED, and I can then connect that to claw number 2, which is where I've plugged it in on my FlowPaw module. I can start my FlowPaw, so we're now connected. So I can now put in some text in here and connect that to the data. So notice I used a string here because it's text. And if I want to send that, there's a little send button here. I can now press send on here, and then that writes the text to the display. Okay, so you get the idea. It's very simple to connect. We can also monitor these buttons on the board. So if I just put some balls on here, we can actually read these buttons. And if I press a button on here, I'm pressing button 1, you can see that goes to true on the screen. Okay, so button 2, button 3, and you can see it's really fast because it's USB. So we could do something simple like get rid of that switch and connect the output of the button to the input of the LED. So now when I press the button, the LED comes on too. So to give you a little idea how to use the buttons. Okay, let's add some more claws. I'm going to disconnect it, and I'm going to add a proximity sensor, and what else should we put on? An accelerometer and a buzzer. Okay, so these are the 4 standard claws that you get with the FlowPaw kit. Plug that back in. Okay. So let's bring in something else. Let's bring in our proximity sensor, and that is on claw number 1. And I can start the FlowPaw first and connect the claw second. Doesn't matter which way around you do it. And if I just pop up an F for float, we can now monitor the proximity, which is basically how close you are to the board. So when I'm really close, it goes up to almost 1, and then depending on the ambient infrared light, you can see that in real time. So we could put a meter on here, for example, and now we've got an indication of the level. Okay. If I bring in the buzzer here, which is on claw number 4, here we've got 3 inputs for you to control. We've got frequency, tune, and play. So frequency, as it says here in the writing, is actually a frequency 50 Hz to 8 kHz. The tunes are 1 to 49, and the play actually plays the tune. So if I just pop up a tune here, tune number 5, and press play, that's playing, if you can hear that on here. So we can make little computer type noises on the thing, or put in a actual frequency. Okay, let's have a little look at some of the examples that come with the FlowPaw. I'm going to close that down. Okay, a few open and open. So when you install the FlowPaw, you get a folder which is called FlowPaw examples. So there's all sorts of little projects in here that you can play with. If I open something like Pong, this is a game, and it's using the accelerometer to control the bat. So you've got this bat controlled by the computer and this one controlled by the FlowPaw board. So if we start this on here, I can actually move my board to actually play the game, which is quite difficult with one hand. So we get the idea. And the sounds are also coming out of the FlowPaw board. Now the great thing with this is that whilst this is a game, you can also go in and hack the source code, because you have the whole of the source code here. And we've done things like expose the bitmap, so you can come in here, click on the parameters button, load a bitmap from your PC, change the graphic for the bat and the ball and that kind of thing. So it gives kids a lot more scope if they're playing the games, and then they can go in and change them, hack them. You get a lot more learning and fun out of it. So I'll close that one. We've got another retro game in here too. We did Space Invaders, same kind of thing. Only this time we're using the buttons to fire. So that's button 4 is actually firing, and then if I move the board, it controls my ship. Okay. Okay, so let's start with a new project. Let's look at actually writing our own program. And for this one, I'm going to use some different claws. I'm going to disconnect my board, and I'm going to use a temperature sensor. So I've got an infrared temperature sensor, an LED display board, and I'm going to use a relay board. Okay, so hopefully you can see that. So what we have here is an infrared temperature sensor, a 7-segment display board, and a 2-channel relay connected to a little bulb and a battery. So if I start from scratch with my PAW module, we can start the PAW module, and then we need to add some claws. So I need my temperature sensor, which is on claw number 1. Okay, and we can now read the temperature, so that's saying 22 degrees, and if I put my hand over it, it goes up a little bit. We can now add our 7-segment display onto here, which is on claw number 2. Okay, so you can now see that saying 0, 0, excuse me. And if I connect the temperature out to the value in, now the LED display is actually reading the temperature in real time. So it's going up to sort of 24 degrees down to 22 degrees. So it's very easy to control. And now I want to make a decision. So what I'm going to do is say if the temperature is greater than let's say 22.5, I want to switch on my relay. So get my claw relay, which is on claw number 3, and I've got my relay connected to relay 2 with my bulb. So now if I increase the temperature, bulb comes on. Okay, which is quite cool. So we could control all of this over the internet, because FlowStone can talk to the internet and your computer can, so it starts becoming Internet of Things and that kind of stuff, which is quite cool. Okay, so imagine this was a greenhouse and we wanted to open a window when the temperature went over a threshold. We could also do something like connect a servo motor, and if I just put that onto servo 0, hopefully you can see that, we can then also select, using our ball from our greater than, one of 2 values. So if we have 2 values, one at 0, one at 999 for my servo inputs. And if you click on the FlowPaw module, you can see it says set servo 0, range 0 to 999. And we can then just send that to our servo input. We can even set a speed here, so I'll slow it down a little bit. And so now when the temperature goes up, it actually is moving our servo to open the window. And then that a bit faster. Okay, do that again. So you can see we can make some really cool experiments really quickly using the FlowPaw kit. Next, what I'm going to do is show you a little bit of some of the other claws that are available. So I'm going to disconnect the FlowPaw, take the servo out. You've seen the relay, you've seen the 7-segment display, you've seen the temperature. How about RFID? So RFID is one of these contactless radio readers. So if I just delete all of that and get RFID on claw number 1. Okay. Okay, so this reads cards and key fobs and things. So here's like one of these credit card size access keys. And then when I put that over the RFID, you can see it displays a hexadecimal number. Okay. So if I put a different one over, you get a different number. Okay. So we could do a little entry system here. So if we do equals, and for example, if I put a key that I want to work over the RFID and then copy that string to there, so that's now my secret key, and I can now put an LED on there. Okay, so that's now true, but if I remove that key card, it goes false. So that's the good one. If I now try a different key card, you can see that the number is wrong and the door wouldn't open. So a different card. We can go back to our actual key and it opens. So that's a little bit of RFID, which is quite cool. How about we do some speech recognition? If I put this claw in, which is speech recognition, and I'm going to put the relay back in. And so let's just move that so you can see it. Okay, so what this one does is it actually, you can program it with voice commands. So, what's it called? Speak up. So speak up is on claw number 2, and then our relay is on claw number 3. And what I can do, this will actually output an integer of up to, I think, 200 messages. So 1, 2, 3, 4, 5, 6, 7, 8. I've just programmed 0 and 1 to be control the lights. So if we start that there, with a bit of luck, light on. No. Light on. Okay, so I've obviously done something not quite right. Let's have a look, see what the message is. Let's just test our relay. Yeah, that works. Oh, I know what it is. It is inverted, the output. So Okay. Lights off. Light on. Lights off. Lights off. Lights off. Okay, so you can see that sort of works, which is quite cool. Okay, what else shall we have a look at? Let's disconnect that. Let's have a look at doing a little bit of Ruby programming. So inside FlowStone is a whole programming language which is called Ruby, which is one of the modern languages used for internet. I believe Twitter was created using Ruby as an example. And we've integrated the whole of this language into FlowStone. And we actually won an award in Japan for this a couple of years ago because it's a sort of seamless integration. And what we can do with Ruby is program anything. As you saw earlier, we programmed the computer games. The back of them was all programmed with Ruby. And I'm going to show you how to start with a bit of Ruby code. So to make it real, let's bring in a proximity sensor and let's have a look at the value of that. Okay, so you can see that the sort of noise level of our proximity sensor is about 0.42, and then if I put my hand on it, it goes up to almost 1, and if I put a meter on there, we can see where we're at. Okay, so now I want to do a little bit of signal conditioning. What I want to do is do a bit of an equation onto this value. So first of all, I'm going to make the input of the Ruby module a float so that it's a real number. And we've got a new feature in FlowStone because this is the latest version, which should be able to download for your FlowPaw any day now. If you click on this little plus symbol, it's got some code snippets, and it enables you to just insert bits of code without having to type them. So we've got a simple equation, for example, and this is outputting the input times 2. So you can see the input is 0.4, the output is 0.8. So we could do something like, if I did the input minus 0.42, you can now see that our level has come down, our noise level. Okay, so I'll just get rid of that so you can see what it was before. Okay, and then I put minus 0.42. Now, what you may have noticed is I'm actually typing this in real time. This is an interpreted language, which means that the code is actually interpreted in real time, so there's no compiling, which is really cool. So now we've got a little bit more gain because it's times 2, and we've got no noise. That's really quite cool for your first little bit of code, and it's great you can just do one line at a time. If you want to do something else with Ruby, maybe let's just get rid of the FlowPaw for now. We can do things like draw onto the screen. So if I delete that, I can now load for my drawing snippets of code. Let's load graphic paths. So here's a bit of code to draw some graphics on the screen. I just need to make the input into a view, which is basically graphics. And you can see here we've now got some code which has drawn this shape. If we look at the code, we've got a pen here with a colour. We've got a brush also with a colour. We've got a path, and then within the path we've defined an add line, an add arc, an add curve, and a close figure, which sort of closes the end, and then finally it actually draws the path. So if I change some of these numbers here, we can see that we can actually change the drawing in real time, and we can change the colours here one was alpha channel. Okay. Actually play around with code, which is quite cool. So that's the sort of draw mechanism. There's other things like interaction. We can do things like a message box, and here we've got mouse handling. So if the mouse is true, it then pops up a message box saying, "Are you sure?" So here you can see the hand goes to a mouse, and then when I press, it pops up our message box. Okay, let's load some more. Maybe a drop list. Here, if I right-click, I get a drop list. Apple, banana, orange, and pear, which is obviously written here. So that enables us to learn coding very quickly by just hacking stuff that's pre-made, or you can just go in at the beginning and just sort of type your own events, that kind of thing. And in FlowStone, the main event is called an event, which is like a function, and it has 3 variables. I is the index of the input, because we can have multiple inputs into our Ruby module. V is the actual value of the data, and T is the time the event happened. So we can just do, output at in, output 0 at in, and if we make that a string, we can just put something in here, change the output to a string, and type something. You can see it comes out, and then we can start doing the maths on it. So output input times 2, because it's a string, you get hello. Or if we change the inputs to floats, we've now got numbers. So 5 times 2 is 10. So it's very easy to build our own code in the Ruby module. So that's probably enough for today, just to get you going on the FlowPaw module. We're now going to throw it open to questions and answers. So if anyone's got any questions, please go ahead. I hope you enjoyed the presentation. Thank you.
So, Carl, we have some questions. I will read them to you. First question is, does it also work when you finish coding and plug off USB? And will the program work again if you simulate an electric blackout of the paw?
Sorry, could you say that again? I missed the first part of the question.
Should I read it again?
Yes, please.
Does this also work when you finish coding and plug off USB? And will the program work again if you simulate an electric blackout of the paw?
If you simulate a blackout of the paw, you just unplug it and plug it back in again. What we can do is we can make an auto connect. So if let me just disconnect my paw and plug it back in again. So you can see that the lights are flashing on the paw, means it's not connected. And if I send a trigger to the paw, it connects. If I then simulate a blackout and disconnect the paw, you see the LED goes off on the screen, and when I plug it back in, it won't auto-connect unless I ask it to. But we can write a very simple little bit of a program that basically sends a trigger, for example, say once a second, and we can do it on a select. So, sorry, the other one. This one. So here this will send a trigger once a second to the start input of the FlowPaw. And if I then send a not value from there, so it's true. So if it's not connected, it sends a trigger, and now it's connected. So if I disconnect my paw now, simulating a blackout, okay, and then plug it back in, it should reconnect, which it has done. So I hope that answers your question.
Yes. How can one control devices with FlowPaw that use 24 volt, 230 volt, or 380 volt input?
Okay, so the relay that comes with the FlowPaw actually works up to 240 volts, so you can actually switch mains electricity. If you're going to control higher currents, then you need to connect it to some other kind of high current relay. So you could actually slave off this relay and connect to a relay that switches on a power station if you wanted. So the main thing is to use the relay as a starting point, and then you can connect other devices which are capable of handling more current to that. Okay.
Okay. At the moment, there are no other questions. If you have some questions, please ask them now. We wait a minute. Oh, I see there's writing someone in the chat. No, there are no other questions. Carl, thank you for the presentation.
You're welcome.
And have a nice day.
Okay, thank you everybody. Goodbye.
Goodbye.